No one's talking. I'm just feeling down.
All right, I think we're almost ready to start. I've got a few problems that were submitted via email by people that they wanted to see worked out. So I've got a small list of things I'm planning on doing. So if you guys have any questions about um your assignments, go check them out. If you are in first period, I've left comments on your work um with like, hey, try 1, 2, and 7 again sort of comments. And I'll be getting to the rest of the classes this morning. So if you want to go check that now, if you're in first period, you'll see comments on which ones you want to try again. But everybody else, you'll be hearing back from me shortly via the comments on your working classroom. Still a bunch of people that haven't turned them in, so I guess they're just going to roll the dice and turn it in tomorrow. Hopefully, I hope I don't have a whole bunch of zeros, but yeah, if you have a question about one of the problems in the assignments, like in classroom, go look at them. Maybe you can say, hey, Mr. Matthews, can you show me one like number 8 on assignment 1, something like that. Because right now I have a small list of problems that people wanted me to work out on stream. And other than that, I'll go find stuff to do for you in case you guys, unless you guys want to go find a problem for me to do specifically. So I got 3 minutes to go make sure the kiddos in the house are all set for class time. So take those 3 minutes to go see if there's any problem you want to see worked out. Okay. Well, good morning, everybody. Um, we're gonna do some more exponent work here. The timer, that makes noise. Okay. No more of that. Yeah, Diana, what's up?
I clicked the wrong thing, my bad.
Oh, that's all good. That was just interesting. I saw a raised hand. Novel concept. It's been a while. Now, just as my disclaimer is, if you don't want your small image or face to end up on YouTube, just deactivate your camera now, because once I record this thing, it just randomly shows little people's. Okay. So let me get a blank screen here real quick. Okay. So today we're going to be starting with some submitted requests from Classroom. Now I'm on new monitors and new computers, so I'm hoping I don't have any technical difficulties. But if there's anything going on where you guys can't see something, please holler, because this is a little bit of a different perspective for me. Okay, so let's see. All right. The first question comes from assignment number 2. No, it's assignment number 1, number 2. Okay, so something like this. This isn't the exact problem. I am changing it just a little bit. Okay, so the question is, how do we evaluate this expression? We've got two exponential expressions with the same base. They both have just an x as their base, and they are being multiplied together. What do we do? So there is a shortcut, but just to explain it, this term right here is the same as 1 times x 4 times. You know what? Let's do it like this. It'll just be faster if I type it. Probably easy to read too. Oh, let's make it big. 1 times, x's. You know what? This is why people stop using the multiplication symbol as an x. This exact situation. Okay, let's change this just a smidge. Let's say it was g to the 4th times g to the 10th. Okay, so we're going to make an abstract rule out of this. And when I say abstract rule, I should pull up my math practice standards while I'm here. Copy that. That should be a good spot. Okay, so what we're doing right now is we are going to be reasoning abstractly. When I say abstractly, what I mean is we are going to be making up like our own little rule that we can use forever for math practice set number 8, making repeated reasoning. So, okay, back to the rule. Okay, so this is going to be 1 times g 4 times. That's what that first term is. And this second term is 1 times g 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Gotta count, make sure that's all of them. This is why they developed the rule, because no one wants to do this over and over and over again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if we were multiplying these two things together, really what you end up doing is counting how many g's you have. So there's supposed to be 4 there. I missed one. Now I gotta be sneaky. Okay, so like I said, oh, goodness gracious, options. Here we go. Technology is awesome. Okay. Back to saying smart things. Okay, so so there's g to the fourth power, and there's g to the 10th power. So what some mathematicians realized, okay, well, if I'm multiplying two exponential expressions together that had the same base, this case the base being g, I just kind of end up with an added, that's 14 g's. So the abstract rule became that you just add the exponents together. So this would be g to the 4 plus 10. So the answer would be g to the 14th. So that is the first request I had via email this morning, is how to do a problem just like number 2 on assignment number 1. And this rule can be applied even when you get negative exponents. It actually makes negative exponents a whole lot easier to understand when you get them in this way. Like if you had gotten a problem, let's say that was, oh, I don't know, m to the 5th times m to the negative 12th, and you start panicking like, oh my goodness, what do I do? Negative exponents. Well, the rule still applies. You would just do 5 plus a negative 12. And because we're all pros at our 7th grade math standards, 5 plus a negative 12 would end up being a negative 7. So yeah, anyway, so that is one of the rules that I was requested to go over. And if you guys want more of those, we can do more. But let me go ahead and get on these next 2 because I think, yeah, that's actually a pretty cool coincidence. The next 2 problems that were requested by different people also apply to this. So I can actually leave some of this on the screen, I think. Let's go ahead and just move this a little bit. Move you a little bit. And we'll gotta get you out of the way. Okay, so here's the next one that was requested. 4 to the 6th power being multiplied by 4 to the negative 8th. Okay, whoa, that is a horrible parentheses. Let me try that again. Okay, so what we're going to be doing now is math practice stand number 8, making use of repeated reasoning. Like basically, we just figured out this rule works, so let's use the rule again. So based on what we just did, this is going to be 4 to the 6th plus a negative 8. My right side parentheses are horrible today. Try again. Okay. So now it's just a matter of whether or not you know what 6 plus negative 8 is. If you're 6 steps up and you go 8 steps down, you are below where you started. So we're going to be negative. So this would be 4 to the negative 2nd power. I guess we could also argue we're being very careful with our numbers, so we're attending to precision. That's math practice standard number 6. We're kind of modeling with mathematics, just writing out our equations. I'm making pretty good arguments, I think, for why these work because I modeled it. I modeled it on the last problem. So yeah, so there's that one, and you can see how similar that is going to be to this next one right here. So this is the same skill basically, even though it's wrapped up a little bit differently. So this one is y to the negative 4th times y to the 3rd. So those of you that are in chat, what do you think the answer is going to be based on what we just done? You can type it out or you can say it, either one. I'm pretty sure you might even be able to write on this if you use the annotation tool. I'll give you guys a chance before I just blurt it out. Y to the negative fourth times y to the third. What do you think?
Y to the negative third.
Okay, I'm gonna just write down what I hear. So I heard y to the negative third. Okay. I'm seeing in chat y to the negative one. Ooh, I didn't think about this. Maybe we should try some virtual classroom number talks, where I just write down everyone answers and then we can actually annotate the same board. That'd be cool. Maybe I'll try that tomorrow. Anytime I look down like this, it's because my phone is pinging and I'm just trying to make sure it's not a parent or student or other. Okay, y to the negative first. Okay, it seems like we have. Okay, maybe someone said. Okay. So yeah, so this one. So, okay, so this would end up being y to the negative fourth plus 3. So yeah, that you're right in chat. That is going to end up being y to the negative first power. Mm-hmm. And for any of you that get like really weirded out by negative exponents, it's not that big a deal. I'm going to go off on a bit of a tangent here, but it's good stuff. Okay, so that is the right answer for that. But if we're going to talk about negative exponents, just to give you guys more comfort with it. So this is going to be lame if I try to type it. Okay, so actually, let me get a brush. This will be easier to read probably. All right, so when we say x to the third power, that is 1 times x 3 times. So the difference is that when I say, grab a different color, when I say x to the negative third, it's just the opposite of that. The negative symbol in this case is being used as a symbol of opposites. So this would be 1 divided by x 3 times. That's all that means. Now, we have a way of writing division. We call those fractions. So this would be 1, the way we write that is 1 divided by x 3 times, which is basically 1 over x to the third power. So whenever you see a negative exponent, just think of it as like, oh, that's just going to go in the denominator. That's the best way to say it. But I will tell you, in the history of my math career and education, this is the one time the negative symbol means the opposite of more than anything else. It was probably the time when they really clicked with me, like, oh, it's the opposite because we're just dividing. Okay. So we've been going on here for about 20 minutes, and unless someone has, and I will check, submitted me another question via email or remind or anything else, and unless you guys have one you'd rather work out, I can go ahead and start grabbing stuff for us to practice. So I'll give you guys a couple seconds to look around and check. If you want to go look at your assignments real quick and say, oh, hey, how about number, blah, blah, blah. Especially if you're in my first period, because like I said at the beginning of the stream, first period students got their responses for which ones they need to try again. I'll be getting into second, fourth, and sixth period here after my streams. So before tomorrow, like will be the last chance. Tomorrow will be the last chance to say, oh, hey, how do you do number so-and-so before we won't see each other until Monday, probably. So take a second and go look. That's because you got hundreds on both, Tate. Lol, lol, lol. Okay, so Tate, did you look at Classroom and it did not show you the grades? Okay. Yeah, I've got to get better with how the classroom assignments function. Since I used to put them just straight into I now, it never really mattered. But now this is a new era. So let me check something. First period. Okay, if I just select you. Okay. Aha. All right. So Date, you should be able to see assignment 1 now. And then you and Humina both got hundreds on the second one, so I sent those back to you. Okay. Great. Any moment now, Tate's gonna wonder, wait a minute, if I got hundreds on both, do I still need to be here? Oh, wouldn't that be fun? If we were in class at school and the rule was, hey, if you get 100 on your assignments, you can leave. I wonder how much attention would just spike. Okie dokie. It's a fun time when you are so bored that being on stream doing math problems is the place to be. But I hear you. It's a weird day. At least it's pretty today. Hopefully everyone will have a chance to get outside and run around. Okay. Well, I will start pulling work then. You gotta stop me if you suddenly realize, oh no, why would I go back and do this?
Well, shut. What?
For those of you that are here, I'm gonna ask you for your opinion. If I did 20 minutes of reading on stream, like as an additional thing, I just decided to read a book every day. What book should I read on stream? I was gonna go grab a Harry Potter, but maybe there's one you guys are like, no, read this. So now the question is, do I start with number 1? I'm tempted to shoot straight to number 5, Order of the Phoenix, because it's my favorite. It's like one of the longest ones though, but it's good. Read a Shakespeare book. I could probably swing that. I should be more familiar with Shakespeare. Really, which Shakespeare are you learning with Elliot? Is one in particular, or just kind of like all
Midnight
Shakespeare?
Summer, I think is what it's called.
Midsummer Night's Dream.
I just do it to you, and
It's a Midsummer Night's Dream. Yeah, I could probably swing that. I bet I could find a copy. Yeah, I think that'd be more fun. I'd rather read what you guys are reading, and that way maybe I can give you guys some insights on how that goes. So yeah, that'll be the plan. I'll find myself a copy of that. But for now, hey Tan, if you look at your options, you probably have a button you can depress to unmute yourself when you want to talk. That way you don't have to leave your mic open. I think it's defaulted maybe to spacebar. Someone else can probably chime in the chat on that. Dun, 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 dun. So I've got some noise dampening set up, I think, so you guys can't hear, but I need, like, let me know if you can hear the 5-year-old in the next room. She sounds like she's pretty excited about something. Bottom left of the screen is where you can see. Is that where you unmute yourself, or where you can see which button it is to like temporarily unmute yourself? Yeah, yeah. But I'm saying that in the software, there's like going to be a keystroke where you can just press the button and hold it to talk, and then let go, and it'll go back to muting yourself. In other programs, it'll be called push to talk, but I think in Zoom software they call it like temporarily unmute yourself. That's how they phrase it. Anyway, like I'm gonna mute myself here for just a second. Be right back.
Ooh.
There, now you can hear me. Okay, so if I let me zoom in on this.
This was the exact same problem I had yesterday.
Yeah, well, look, if this is one of the best parts of the con, it'll tell me like, so out of the 9 people that have gotten this exact problem, 6 people missed it. So based on the abstract rule we were just talking about, it even tells me like what their answers were. So based on the abstract thing we were just talking about, what should the answer be? 5 to the negative 8th times 5 to the negative 10th. Trying to see if I can fix. Oh, that's what I want. Okay. So this should be worked out as 5 to the, let me write that bigger. Undo, undo, undo. Okay, so this should be 5 to the negative 8, because they have the same base. That'd be 5 to the negative 8th plus negative 10. So what is negative 8 plus negative 10? If you're going down 8 and then down 10 more, what will we get? 5 to the what? I heard it. Yep. I think I heard it. 5 to the negative
18.
Mm-hmm. Let me see. I was hoping there would be some option where I could give some like a virtual high five or something, but apparently not. I can make someone. a special camera, but no. Yep, I heard multiple people say it, and yes, in chat. Yeah, awesome. That's it. So you just combine the two exponents. All right, let's look at the next one. So now, so this is one's an even more drastic issue. Out of the 6 people that got this one, 5 have missed it. So okay, so the best way to understand these is I've got 7 Z's on top. I've got a video that I've already pre-recorded for class where I talk about canceling out. All right, so here's how you think about this. This is a fraction with 7 Z's on top. It's 1, 2, 3, 4. Getting my virtual Zorro on. 1, 2, 3, 4, 5, 6, 7. Okay. So I've got 7 Z's on top, and heaven help me, I've got 14 Z's on the bottom. Again, we talked about this a few minutes ago. When you have a negative exponent, that just means that those go on the bottom. Wait, hang on. Ooh. Did they really do that? Z to the negative 14th is in the denominator? Hang on. Okay. I'm having a bit of a moment here. So, oh my goodness. Okay. So I almost made a boo-boo of myself here. They put z to the negative 14th in the denominator. So really, this is z to the 7th being divided by z to the negative 14th. Huh. Okay. So that would be z to the 7th. And that would be divided by, this is so weird because usually this would be, okay, so hang on. So that would be z to the 7th being divided by 1 over z to the 14th, because that's what the negative exponent means. Okay, so reach back. 6th grade. How do you divide by fractions? Does anyone remember the jingle? It's 3 letters. Does anyone remember? You swap something. That is true, chat. Yes, Tiana is on the ball. Keep, change, flip. This is not a chicken restaurant. Keep, change, flip. So so this is z to the 7th being divided by z to the negative 14th, which really means we're going to do, so z to the 7th would be like z to the 7th over 1. So we'll keep that the same. So that's going to be z to the 7th over 1, keep, change the multiply, and flip. So this would actually be to the 7 z to the 14th over 1. Oh man, this one twisted. They really threw that 6th grade standard in there very subtly. So now it goes back to what we were just doing. What is z to the 7th times z to the 14th going to be? Using the rule we just practiced a whole bunch. Come on, Chad, be there for me. Z to the 7th times z to the 14th would be what?
Z to the 20.
Bingo. Thanks, Michael. So that'd be z to the 21st. Oh, man. Looking back, now I really like this problem because it really made me think and engage in all like my My math powers. Okay, so let me just go ahead and say what I thought this problem was at first until my brain started pumping the brakes. And I'm really hoping all of you develop that skill with your exponents when you start working out a problem, and then something in your brain says, hey, slow down, wait a minute, there's something goofy here. So here's what I thought the problem was. Okay, so we're going to go ahead and remember that this is the right answer. Oh, actually, that's actually not, hang on. I thought that was a weird zoom. It's this one, z to the 21st power. Okay. So what I thought the problem was, okay, here's what I thought the problem was. I thought it was z to the 7th over z to the 14th. My brain just didn't see the negative symbol at first. So the speech I was about to launch into for canceling out, which would have been a boo-boo, would have been that there would be 7 z's on top. 2, 3, 4, 5, 6, 7. Let's see if I can make those any larger. 1 second. That format. Oh, that's better. Okay, so there would be 7 z's on top, and then there would be, goodness gracious, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 z's on bottom. And if that was the problem, then we could cancel out 1 here, 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 and you get that's how it goes, because anything divided by itself is 1. So that was the speech I was about to launch into, but I would have been wrong because of that negative symbol. And then the answer would have been 1 over z to the 7th. But, oh, goodness gracious, I'm glad I noticed. Okay. Let's see what this next one. Okay, so yeah, so here this will be the cancel out demo. So this one is what I was just explaining about. Okay, so this problem right here, if we were to expand this problem out, this would be 5 to the 10th. This would be 5 tens in the numerator, and then 12 fives. I mean 10 fives in the numerator and 12 fives in the denominator. Misspeaking. So this one, let me see if I can. So this would be 5. That's 1, 2. That's not going to fit in this font. Font. Let's go down to this. Okay, so this would have been 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all over 1. Ooh, can I just be clever? Nice. So that's 10, that's 11, and that would be 12. Okay. Okay, so here's the expanded form of, this is the expanded form of this problem. So there's 10 fives on the top and there's 12 fives on the bottom. Now, the abstract rule that we are totally going to abuse right now is this one. What is anything divided by itself?
1.
Just one whole, right? Okay, so you could look at this. So that's 1, that's 1, that's 1. So these all make whole numbers. And then eventually we run out of 5s on the top. Okay. So this is basically 1 times 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 1. And then what we have left over is over here. So essentially, dun, 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 dun. So here's our answer right here. What we have left once we have it's our question here is to rewrite. So we're rewriting this. So basically what we get left over with is 1 over 5 times 5. That's all that's left. We can do no more. We can't simplify anything else. These are all whole numbers. So the answer would end up being 1 over 5 squared. It could also be written out as, yeah, let me see if I can move this. Ooh, sweet. So what are the other ways that might show up? And I could look here, but that might also show up as 5 to the negative 2, because we were talking about that earlier, how that's the annotation for doing your exponents in the denominator. It might also be 1 over 25. It could be written any one of those ways. So let's see. Oh, I see 5 to the negative 2 is right there. Yep. So that's how exponential expressions get simplified when they're in numerator denominator like fraction form. And the math word of canceling out is when you literally just start crossing out the same base on top and bottom, because anything divided by itself is 1. So what mathematicians start saying is, oh, they cancel out. And that's a really, really quick way to clean up your fractions. Yep. Okay, I think we've done enough of this particular standard. Let's move on to something a little different. Okay, so here's one that of the 9 people that got this particular problem, 7 people missed it. So we probably really want to talk about that. Okay. Yeah, this one looks gross, but it's really not as bad as you might think. Okay, so we have a fraction here of 8 to the negative 5th. By the way, is this zoomed in enough? Doesn't seem like the problem's getting that much bigger. Okay. Yep, that's about as good as it's going to get. Okay, so 8 to the negative 5th divided by 2 to the negative 2nd, all being raised to the negative 4th. Okay, so here's the rule. When you have a fraction and that fraction has a numerator and a denominator, oh, and they can, by the way, they could be any letters. They don't have to be the same. And they have exponents attached to them. So this could be like x squared. This could be g to the 3rd power. And it's nested in a set of parentheses. And then they are all being raised to a power. I don't know. So here's what you're going to do. You are going to apply this to both of the exponents. And our abstract rule for powers of powers is they get multiplied together. So this is going to be the same as x to the 2 times 10 over g to the 3 times 10. Yep, that's what it ended up being. So there's our abstract rule. So you'd end up with x to the 20th over g to the 30th. Now with that rule in place, let's use some repeated reasoning. and help these 7 people out that missed it. And drag that away. Okay. So if that's how this works, what will we do here? This would end up being 8 to the negative 5th times negative 4 over 2 to the negative 2nd times negative 4. So now we have to just so now we're taking the 8th grade exponential structure and using 7th grade integer skills. So what is a negative 5 times a negative 4? Come on, chat, be there for me. What is negative 5 times negative 4? Close. The rule for negative times negative.
20.
Negative times negative is positive, so this would be 8 to the 20th.
Negative 5 times negative 4 would be 20.
I agree, Tam.
Well,
by the way, I can't. You guys give yourself these such cool names. And if I mishear someone, and if you chime in and it's like, hey, that wasn't Tiana, or whoever's voice I say it was, please correct me. Please correct me. I don't want to be that guy. But if you correct me and say, no, it was me beasting in Bama, might not know who to compliment. Uh-oh. Now the teacher chat's all about plagiarism. If you guys don't know what plagiarism means, it means copying each other. So that's what the other 8th grade teachers are discussing right now. If anyone else is having problems with plagiarism. All right, so 2 to the negative 2nd. So what is negative 2 times negative 4? Repeated reasoning. We just talked about it.
8.
Bingo. I think it was Michael. Yep. So 8 to the 20th over 2 to the 8th. That's got to be one of the answers. Yep, I can see it right there. That was a horrible line. Let me back that up. I can see right here is B on the assignment. Yep. That would be 8 to the 20th over 2 to the 8th. Okay. Every now and then I'm going to check over and just see if anyone has sent in a question. Not yet. Okay, so let's see what the what's this other one that's so many people. Okay, so again, math practice standards. Let's use some repeated reasoning right here. So what we just did should work on this one as well. So I want everyone to take, I don't know, a minute and get an answer for this one. So if you're in stream on your paper, I want you to get an answer for this one. It's 4 to the 3rd over 5 to the negative 2nd, and they are nested in parentheses, and that whole thing is being raised to the 5th power. Don't blurt it out yet. For those of you wondering what I'm doing, I'm checking. One of my students who has to submit like emails with pictures of the paperwork just sent me her work, and I was checking to see how she did. That one's right. Mm-hmm. So she needs to try a couple more. Okay, you got about another minute to see if you got the answer. I'm checking one more. Okay, chat, here we go. Oh, let's see. Okay, I've got a couple private answers. Let's see what we see. Okay. So this would be 4 to the third times 5 over 5 to the negative 2 times 5. I had to be careful. My multiplication dots don't look like negative symbols. So that's 3 times 5, negative 2 times 5. So that would be, drum roll, 4 to the 15th over 5 to the negative 10th. Signed, sealed, delivered, forwarded. So nice job. Yep. So that's how those work. And that's really too bad that of the 6 people that not all of you get the same problems, and of the 6 people that got that one, they all missed it. That's rough, because once you understand that abstract rule, it's really not that bad. It's really not. We got 7 minutes left. Let's see if there's something else we can take a look at. People seem to be doing better on this one. Let's see. Ah, good. Here we go. Of the 4 people that got this particular problem, I guess I'm being nice. When I say of the 4 people that got this particular problem, if you've had Monday, Tuesday, Wednesday, and Thursday to do these practice problems, and I know I told you on Monday that the con lessons technically are practice and they are not required, but of course, to do well on the assignments, you'll have to know how to do these skills. So when I say of the 4 people that got this one, I really wish it was more like of the 14, of the 40, of the 90 students that got this one. But anyway, of the 4 people that got this particular problem, 0 goose egg, nobody got it right. So let's talk about it. What does this mean? We've got 5 to the, we've got a fraction 5 over 2 and it's negative being raised to the second power. Okay. Well, if I were to expand that, that would be whatever's in the parentheses multiplied by 1 twice. That'd be 1 times negative 5 over 2 times negative 5 over 2. Now, there was a rule I've talked about on previous streams with negative values and their exponents. My goodness. If it's got so if you've got a negative base, negative anything, and you're raising it in parentheses to an even, that means you're going to end up with a positive answer. If this had been an odd exponent, I know it would be negative, but so I know my answer is going to be positive. Top times top, that's 5 times 5, which would be 25. And bottom times bottom, 2 times 2 would be 4. So this would be positive 25 over 4. Now I can already see, if I were to scroll down, one of the wrong answers is the negative of that. But no, that is a rule that there were 2 con assignments specifically targeting whether or not the answers come out positive or negative, and how parentheses affect things. And that would have really helped the 4 people here if they had watched those and really studied that. So, yeah, so it would be 25 over 4. All right, let's see if we can find something else with our last few minutes of the stream today. I'm betting this one's going to have some. Yep. Oh, man, I love these. Someone's got a hot mic. Okay. So, of the 8 people that got this, 6 people missed it. And that's okay. So these, I think, are really fun because they're not actually asking for an explicit answer. They want you to decide what the sign is going to be. It's either going to be positive, negative, or 0. So what we learned by looking at this diagram is that B is positive. It's somewhere between 0 and 1. And we learned that C, whatever it is negative. That's all we really need to discern or gather as far as the information goes from the graph, is that B is positive and C is negative. So now we should probably go ahead and look at this equation they gave us right here. Okay, so this is where your brain kicks in and start thinking, okay, if we know that B is a positive value, let me change my color. Okay, if we know that B is positive, what does that make this? If it's negative 3.2 times B, and I'm asking you, chat, if it's negative 3.2 times B, does this whole thing come out to be positive or negative? It come out to be negative. Now C, we agreed, is a negative value, and B is positive. Negative, so this is times negative divided by positive is negative. And then, oh, what? All that thinking, and look what they did to
I'll
us.
talk to you later, Mr. Matthews.
All right, you can watch this. It'll be on YouTube later if you want to come back and watch the last few minutes.
All right.
Okay, so negative 3.2 times positive gives us a negative value. Negative divided by a positive is a negative value. But that doesn't, nothing really matters because it's all being times multiplied by 0. So the answer to this one would be 0. And that's a real struggle. I mean, I feel so bad that out of the 8 students, 6 of them didn't notice that, oh, there's a times 0 in it. Is anything that is an abstract rule we should all have memorized from way back, that anything times 0 would be nothing. But it is 11 o'clock. I've had fun. I thought that was a really great session. A lot of good participation from chat. I love having people submit me questions via email so that I could start the stream with problems that people really wanted to see worked out, that were giving them headaches on their assignments. Just disclaimers. The practice problems on Khan are really meant to help you get through your assignments. The only things that are being graded are the assignments that are posted on Classroom. I will be back tomorrow from 10 to 11. That'll be sort of the last chance for questions. Before tomorrow, every single class. Now, this is only for people that do submit their work early. If you submit your assignments before tomorrow, I'm going to post a comment on your work saying, try these again. If you're in first period, I've already sent those out. Second, fourth, and sixth period will happen sometime here after I get done streaming for the day. I hope everyone's healthy. Hope you're all doing well. I'm going to get me a copy of Midsummer Night's Dream, and I'm going to start reading it maybe 20 minutes a day because I'm sure that's what you're expected to do, if not more. And we'll study some Shakespeare. Miss you guys. See you next time.